Good afternoon, Dr. Hermawan. So today I'll be doing the code review for the projects that I've done throughout the week. Okay, so first we'll start with the facial recognition project. And for the first two lines, okay, first of all, we will import any libraries that we need. And these are basically all the libraries that we need, and it's sufficient for us to complete the task. So for the line 7 and line 8 here, we are trying to use the functions to call out the path of the images folder, which is actually inside the project. As you can see here, the images. After that, we call out the cascade classifier functions, which from its location, and the location which I believe is actually in here, which is this one. And yes, inside the data here, and as we can see, it's right here, the higher cascade frontal face. Yes, right here. After that, we create our own recognizer functions by calling a CV2 functions, which is this one here. And then the labels ID here is actually an empty dictionary for us to store our image later on. Yes, after we have put a label on them. As you can see, these are all the images that I've included in the file for the training purposes. And the Y labels is an array that we are, and the X train is also an array that we are going to use later. So for this loop here, the functions over here, we allow the program to continuously go through the image folder, and to access any folder ends with the format PNG or JPG. As you can see, all of our pictures and images here are actually in the format of JPG. Okay, good. And after that, we are going to create a label ID here, which is we are going to create a label for each of the images here. And after the label is created, after each label is created, we are going to increase a label ID, and the function is going to be like this. And the label ID is going to be stored inside the empty dictionary we have just created just now, which is here. Good. And after that, we will by using the functions over here, as you can see, the final image below image resize, we are going to reframe and resize the images so that we can use the function over here to actually convert all of our images in terms of array by using the numpy function, I believe that this np.array final image uinta. We are going to convert every image over here in terms of numbers of arrays. And yes, for instance, I've already included a function to print the numbers of array that we are going to see later. So, and we define a function faces by using the face cascade functions, and together with the scale factor and also the minimum neighbors equals to 5. Yes. So for every coordinate x, y, w, h in a faces function, we are going to create a function named as the region of interest ROI. And the region of interest has a parameters of this coordinate and this coordinate. And then when the process is done, the training model, which is the recognizer function, will be saved in this file, which is actually here, as you can see. So basically, to run the code here, so basically we are just trying to run the code here, and as you can see, all of these arrays are actually the number of actually the arrays of the images, which has already been converted, as you can see for this one and for this one. So this, for each of these, it actually means this is the number, this is the entire array of one image, and we have a total of, I guess, total of 30 something images. Yeah. So let's proceed to the faces part. So as you can see, we import the libraries that we needed, but I don't think NumPy is needed, so I'm just going to comment this. And then we call out as the same in the previous part. We call a face cascade classifier, yes, from the location which I just shown, and we declare once, and we declare again the recognizer function by using the CV2 functions face recognizer, and then the labels now are actually equals to the person's name, which in here is actually my name, Brian, which yes. And then the OG labels equals to pickle.loadF is actually just a function to load the file's name so that it can be included inside the label. And we initiate our phases using the capture functions. So after the capture function, we assign frame as our function to read. Inside the loop, we are trying to capture the frame. We are trying to capture our video frame by frame. So we assign frame function, and we allow it to read video captures frame by frame. And then it is then converted into a grayscale for our photo operations. And yes, faces function is once again called out using the face cascade and together the scale factor and the mean neighbors. And for every coordinates in the phases, which is the loop part, we are just trying to create the same region of interest array, which is for the gray frame and for the original frame. So here is the part for the conditions when it detected a face. So we actually declared a configuration equals to recognizer.predict. This is actually to predict the region of interest when it's in grayscale. When the configuration is between 4 and 85, we can say that a face is detected. Yes, no, what I mean is only in this region, only when the configuration lies in this range, the color, no, the name of the owner will be shown on the frame. That means if I've detected a face and it has to be on this range to show the name of the owner. If I've detected a face and the range is other than this, it wouldn't show the name of the owner. Then we create a file name 7.png to actually capture our final image. That means when we end this program, this file will contain the final image captured by the camera. And when a face is detected, it will actually draw a rectangle of the color, green color, around the faces with a stroke, basically just mean thickness. And then when everything is done, we release the frame and show the frame out in a different window. And basically this is the coding part for the facial recognition, and now we are going to try and run it. So we have just run faces train and it's working perfectly. So now we just run the faces. So from here I have to share the frame screen. It's better without spectacles because the Hara cascade classifier is kind of sensitive, and as you can see, it's working quite good. Besides that my hair is too long and it may affect the cascade classifier's functionality. So I believe that is so for the facial recognition.